Hello everyone. Now we are going to see an interesting topic, crystal physics. So in this video I am going to give an introduction about crystal physics. So crystal structure first we are going to see. See, before we are going to see the crystal structure, so we should recollect what are matters. So matters, there are three types of matters: solid, liquid and gases. And what basis these materials are under solid category, these materials are under liquid category, and this materials under gaseous category. In what basis classified? The classification is simply based on their atomic structures only. In solid materials, atoms are tightly packed, and in liquid materials atoms are loosely packed, and gases atoms are freely packed. So based on this packing atoms, this is classified. So what are the topics we are going to discuss now? Introduction to crystal physics, then crystalline and non-crystalline solids, why we need a single crystal and how it used in the real world applications. So first, why we need a single crystal. So understanding the fundamental properties of a crystal structure and their types is essential for advancing material science. Yeah, crystal plays a vital role in material science. So each crystal type play a vital role. Yeah, uh, deriving innovation in technology and enhancing performance in numerous fields. So classification in solids, there are classified into two major categories, crystalline and non-crystalline. But this crystalline, it is classified into single and polycrystal. So what is crystalline and non-crystalline? Crystalline atoms are properly seated on the lattice. Lattice is the array of atoms. So atoms arranged properly on the lattice. So this is called crystalline, and this crystalline have a single crystal and a polycrystalline materials. What is single? Only one type of atom is present. It is called a single crystal, and more than one type of atoms are present. That is called a polycrystalline material. Next, amorphous. So what is amorphous? So it's just opposite to crystalline material. Crystalline atoms are properly arranged in a lattice. Amorphous atoms are randomly arranged in the atoms. So this is the difference between crystalline and non-crystalline materials. Next, crystal solids. A crystalline solids. Arrangement of units of matter is regular and periodic. Yes, atoms are arrangement of units of matter is regular and it is periodic, and substance are anisotropic substance, and this crystalline solid materials have a sharp melting point and they possess regular shape. Because why they have a regular shape? Because they are having atomic structure in a proper manner. So atomic structure is proper, that means atoms are arranged in a proper manner. And example for this is iron, copper, carbon, germanium, silicon, then silicon dioxide. These are all example for crystalline materials. Non-crystalline solids. So amorphous materials are non-crystalline materials, and these materials are isotropic substance and have a wide range of melting point. But in crystal materials they have a sharp melting point, but they have a wide range of melting point. An example for this is glass, plastic. So these materials are non-crystalline materials. See, atoms are how they are arranged in a material. It is randomly arranged. Polycrystalline. So more than one type of atom is present, aggregate of many small single crystals, and they have high degree of order over many atomic or molecular dimensions, and they have a grain boundaries, and these grains are usually 100 nanometer to 100 microns in diameter, and polycrystalline with grains are less than 10 nanometer in diameter or non-crystalline materials. And example for this is ionic solids. Most of the metals and ceramics are under this category. Next, crystal structure. So lattice and basis combinedly gives a crystal structure. The unit assembly of atoms or molecules is identical in composition. So applications of crystal, it is its application is enormous application to have. It is used in memory devices, sensors, then fuel cells, catalyst in chemical reactions, then solid state refrigerators, solar cells, electronics. These are all some of the applications of a crystal in the real world. So classification of solids, just recollect the points. Crystal solids based on the 7 crystal system. Crystalline and non-crystalline materials are classified. Based on a crystal system, they have cubic, tetragonal, orthogonal, hexagonal, and rhombohedral. These are all the crystal system structures. Then based on the bonding, ionic bonding, covalent bonding, metallic bonding, molecular bonding, these crystalline materials are classified. Then non-crystalline, they have no sharp melting point and irregular arrangement of atoms. Now it's a time for quiz. How the quartz crystal are used in wristwatch? Yes, it is about its piezoelectric effect. Yes. Puzzle matching. Yeah, 3 questions are here and try to match it. A single crystalline, polycrystalline, and amorphous. Single crystal means single and continuous crystal lattice. Single crystal, only one type of crystal atom is present. So single crystalline. Polycrystalline, multi crystal grains with a boundary. So multi crystal atoms are present. So that is polycrystalline materials. Next is amorphous. Amorphous atoms are arranged randomly. So they have no proper arrangement of atoms. And these are the references for this content. Thank you.